Today we are going to learn about mastering Python generators for data streaming. We'll explore how to efficiently use Python generators to handle large datasets in real time, enhancing your data processing skills.
Welcome to our video on mastering Python generators for data streaming. In today's digital age, data is generated at an unprecedented rate, and handling this vast amount of information efficiently is crucial. Data streaming allows us to process data in real time, but it comes with its own set of challenges, particularly concerning memory resources. Throughout this video, we'll delve into how Python generators can play a pivotal role in managing large datasets without overwhelming your system's memory, aiming for efficient and real-time data processing.
Python generators are a special class of functions that allow you to declare a function that behaves like an iterator. Unlike a normal function that returns a single value, a generator function returns an iterator object with a sequence of values. The key difference is that generators implement lazy evaluation, meaning they yield items one at a time and only when needed, which is perfect for handling large datasets. This lazy evaluation makes generators memory efficient. They are particularly beneficial in situations where you need to handle large data streams or perform on-the-fly computations without loading the entire dataset into memory at once. Common use cases include reading large files, streaming real-time data, and producing infinite sequences.
To create a generator function in Python, we use the yield statement instead of return. This simple change transforms a regular function into a generator. Let's go through an example. Suppose we want to create a generator that yields numbers from 1 to 5. First, define your function using def. Inside the function, use a loop in the yield statement to produce the sequence of numbers. Here's a simple code snippet, def count _up_to _5. For number in range 1, 6, yield number. When you call this function, it returns an iterator object. You can then use next to get each subsequent value or loop through it using a for loop. Unlike normal functions, the state of a generator is saved between calls, allowing it to pause and resume where it left off.
The yield statement is central to the functionality of a generator. Unlike return, which exits a function, yield provides a value and pauses the function's execution, allowing it to resume later from where it left off. This behavior makes generators exceptionally memory efficient because they only generate data as needed. This is crucial when dealing with large datasets or streams because the entire dataset is not loaded into memory at once. Instead, data is processed one item at a time. Use yield when you want to iterate over a sequence without the overhead of creating and storing the entire sequence in memory. For example, generating Fibonacci numbers can be efficiently done with a generator, where each number is produced only when requested. Handling large datasets is a common challenge in data science and software development. When working with such data, memory efficiency becomes a top priority. Generators are ideal for these situations as they manage data in a lazy, on-demand fashion. For instance, when iterating over a large file, such as a multi-gigabyte CSV, using a generator allows you to read and process each line one at a time, rather than loading the entire file into memory. This approach is not only memory efficient but also enhances performance and responsiveness. In real-world applications, generators are often used in data pipelines, streaming analytics, and other scenarios where handling large volumes of data efficiently is critical.
Generators can be effectively combined with popular data processing libraries like Pandas and NumPy to enhance data pipeline efficiency. These libraries are optimized for data manipulation and analysis but often require data to be loaded into memory. By using generators, you can feed data into these libraries one chunk at a time, maintaining memory efficiency. For example, you can use a generator to read data from a large file and pass each chunk to Pandas for processing. This approach not only conserves memory but can also speed up processing times by allowing simultaneous reading and processing of data. Integrating generators into your data pipelines can significantly optimize performance, especially when dealing with large-scale data operations.
One of the most compelling applications of generators is in real-time data streaming scenarios. For instance, when scraping data from websites, a generator can yield data as it becomes available, allowing for immediate processing. Similarly, when dealing with live data feeds or APIs, such as Twitter's streaming API, generators can handle continuous data flow without memory overload. Consider an example where you want to stream and process tweets in real time. A generator can yield each tweet as it arrives, enabling real-time sentiment analysis or data visualization. This method ensures that your application remains responsive and efficient, even during high data throughput periods. When using generators in production, several best practices can help ensure optimal performance and reliability. First, optimize your generator logic to minimize any computational overhead. Use built-in functions and libraries whenever possible, as they are highly optimized. Handle exceptions within generators gracefully to prevent data loss or application crashes. Testing and debugging are crucial. Use unit tests to validate generator outputs, and consider using tools like PDB for debugging. Avoid common pitfalls like altering the data source while a generator is running, as this can lead to unexpected behavior. Finally, maintain thorough documentation to aid future development and maintenance efforts, ensuring that your generator-based solutions remain robust and efficient.
In conclusion, mastering Python generators for data streaming allows for efficient and effective handling of large datasets in real-time applications. Throughout this video, we've explored the unique advantages of generators, from their memory-efficient design to their seamless integration with data processing libraries. Their application in real-world scenarios like web scraping and live data feeds showcases their versatility and power. To truly master this topic, I encourage you to practice by implementing generators in your projects and explore further resources to expand your knowledge. Thank you for joining us, and happy coding.